There is a profound stillness that descends when the sun retreats below the horizon, a quietude that belongs not to the bustling day, but to the eternal velvet expanse of the night. It is here, in the deepening shadow of the earth, that we find our oldest companion and our grandest mystery. If you were to walk out away from the glow of the cities, away from the artificial lights that compete with the heavens, and cast your eyes upward, you would see the architecture of our home. Across the dome of the sky stretches a faint, luminous band. It looks like a brushstroke of pearlescent white paint on a canvas of charcoal, or perhaps a river of mist flowing silently through a landscape of darkness. This is the Milky Way. It is the galaxy we inhabit, seen from within. We are not looking at it from the outside. We are embedded in its suburbs, gazing through the density of its disk. To the ancients, before the invention of the telescope, this band of light was a puzzle of divine proportions. They did not know that they were looking at the collective glow of billions of stars, so distant and so numerous that their individual points of light merged into a single, seamless radiance. They saw only the glow. The Greeks called it Galaxias Kyklos, the Milky Circle, a name that gave birth to the very word galaxy. In Eastern folklore, it was known as the Silver River, a celestial stream separating lovers in the sky, bridged only once a year by the wings of magpies. There is a comfort in these old names. They remind us that for as long as human beings have possessed the capacity to wonder, we have looked up at this same structure and felt a sense of belonging. We have always sought to wrap the cosmos in stories, trying to bring the cold, distant majesty of space a little closer to the warmth of the human heart. But let us peel back the mythology and look at the reality, for the scientific truth of the Milky Way is far more majestic than any legend. When you look at that hazy band, you are looking at the main disk of our galaxy. The Milky Way is a spiral galaxy, a vast, flat pinwheel of stars, gas, and dust. Because we are inside this disk, looking towards its edge, we see a concentration of stars. It is similar to being in a forest. If you look up, you see the blue sky between the branches, but if you look horizontally through the trees, you see a thick wall of wood and leaves. The Milky Way's band is that forest of stars, viewed edge-on. It was the Italian astronomer Galileo Galilei who first dissolved the mist into reality. In the year 1610, he turned his simple telescope toward that cloudy arch and discovered that it was not a cloud at all. It was a multitude of stars, packed so tightly together that the naked eye could not resolve them. In that moment of quiet observation, the universe grew exponentially larger. We realized that our sun was but one among many, a single grain of sand on a beach of unfathomable size. Consider the scale of this structure. If you could travel at the speed of light, 300,000 kilometers every single second, it would take you over 100,000 years to cross from one side of the Milky Way to the other. To put that in perspective, 100,000 years ago, human beings were still using stone tools and huddling in caves against the ice. The light that reaches your eyes tonight from the far side of the galaxy began its journey before the dawn of civilization, before the pyramids, before the written word. When we look up, we are not just looking into space, we are looking back into time. What does it feel like to exist within such vastness? It should not make us feel small, though our physical stature is tiny. It should make us feel vast, for we are the part of this galaxy that has awakened. We are the atoms of the Milky Way that have come together to form eyes and minds capable of looking back at the source of our creation. The galaxy is home to a staggering population. Estimates suggest there are between 100 billion and 400 billion stars in the Milky Way. 400 billion suns. Some are red dwarfs, cool and quiet, burning their fuel with miserly slowness that will allow them to live for trillions of years. Others are blue giants, raucous and bright, destined to explode in violent supernovae after only a few million years. And orbiting these stars are planets, worlds of ice, worlds of rock, worlds of gas. We now know that planets are as common as stars. The galaxy is crowded with potential, yet despite this crowding, the distances between the stars are profound. The nearest star to our own Sun is Proxima Centauri, located just over 4 light-years away. 4 light-years may sound like a neighborly distance, but in human terms, it is a chasm. If our Sun were the size of a ping-pong ball in New York City, Proxima Centauri would be another ping-pong ball in Atlanta, Georgia. Between them would be nothing but empty space, a vacuum of silence. This is the paradox of the galaxy. It is incredibly full, yet mostly empty. We reside in a quiet neighborhood of this metropolis. We are not located in the frantic, crowded downtown of the galactic center, nor are we out in the desolate rural edges. We live in the Orion Spur, a bridge of stars located between 2 major spiral arms, the Sagittarius Arm and the Perseus Arm. We are about 26,000 light-years from the center of the galaxy. This is a fortunate location. We are far enough away from the dangerous radiation and gravitational chaos of the core to allow life to evolve in peace, yet close enough to the heavy elements of the disk to build a solid planet. As we lie here, carried by the rotation of the Earth, we are also moving through the galaxy. Nothing in the universe is truly still. The Earth orbits the Sun, and the Sun, dragging the entire solar system with it, orbits the center of the Milky Way. We are moving at a velocity of roughly 828,000 kilometers per hour. It is a speed beyond our comprehension, yet we feel nothing. The motion is smooth, frictionless, a silent glide through the interstellar medium. This great orbit is slow. It takes the Sun approximately 230 million years to complete one single lap around the galaxy. We call this a galactic year or a cosmic year. The last time the Earth was in this specific position in its orbit, dinosaurs were just beginning to rise to dominance. The continents of our planet were shaped differently, fused together in the supercontinent of Pangaea. Flowering plants had not yet evolved. In the time it has taken for the galaxy to turn just once, entire eras of life have risen and fallen on our little blue world. It is a reminder of the patience of the cosmos. Why does the galaxy look the way it does? Why is it a disk? It comes down to the conservation of angular momentum, a fundamental law of physics that governs the dance of spinning things. When the galaxy began to form from a primordial cloud of hydrogen and helium, gravity pulled it inward. As the cloud collapsed, any slight rotation it possessed was amplified, just as an ice skater spins faster when she pulls her arms in. Over eons, the collisions between gas particles smoothed out the chaotic movements, flattening the cloud into a pancake shape. The stars we see today were born within that spinning disk, and they continue to follow that ancient momentum. However, the Milky Way is not perfectly flat. If you were to look at it from the side, you would see that the disk is warped, twisting like a vinyl record that has been left in the sun. This warp is likely caused by the gravitational tug of two small satellite galaxies, the large and small Magellanic Clouds, which orbit the Milky Way like moths circling a street lamp. Their gravity gently pulls at the disk, creating a wave that ripples through the structure of our galaxy. It is easy to think of space as silent, and indeed, sound cannot travel through a vacuum. But if we could translate the electromagnetic waves of the galaxy into sound, we would hear a symphony. We would hear the crackle of lightning in the atmospheres of Jupiter-sized planets, the rhythmic pulsing of rotating neutron stars, and the hiss of radiation from the remnants of supernovae. The galaxy is alive with energy. Tonight, as the air cools and the world settles into sleep, the Milky Way hangs above us, a constant presence. For most of human history, this view was available to everyone. A shepherd in the hills of Judea, a sailor on the Pacific, a farmer in the rice paddies of ancient China, they all looked up and saw the same river of light. Today, artificial light has washed out this view for many of us. We have traded the starlight for streetlights, but the galaxy is still there, waiting behind the veil of our own making. When you find a dark place, or perhaps just close your eyes and imagine it, you can sense the depth of the view. The dark patches you see in the Milky Way, often called the Great Rift, are not empty spaces. They are vast clouds of interstellar dust, thick and cold, blocking the light of the stars behind them. These are the curtains of the galaxy, hiding the backstage machinery where new stars are being assembled. There is a serene beauty in this dust. It is composed of tiny particles of carbon and silicon, the same elements that make up the rocks of the earth and the cells of your body. In a very literal sense, we are made of stardust. The atoms in your right hand may have come from a different star than the atoms in your left. We are the children of the galaxy, born from its recycled material, breathing its atmosphere, looking back at our origin. As we drift deeper into this journey, let us consider the concept of home. We usually think of home as a house, a town, or a country. But in the truest sense, the Milky Way is our home. It is the island of gravity that holds us together against the expansion of the universe. Beyond the edges of our galaxy lies the intergalactic void, a region so empty and so vast that the human mind recoils from it. But here, within the spiral arms, there is light, there is matter, there is gravity, there is a cosmic embrace. The Milky Way is not merely a collection of objects. It is a system, a working organism of gravity and light. It recycles itself. Stars die, blowing their enriched material out into the void. This material cools, condenses, and collapses to form new stars. It is a cycle of birth and death that has continued for over 13 billion years. The galaxy is a garden, constantly tending to itself, growing, changing, evolving. And what of the light itself? The photons striking your retina when you gaze at the Milky Way have traveled across the vacuum without hitting anything for thousands of years. They have dodged dust clouds, missed planets, and avoided the gravity wells of other stars, only to end their journey at the back of your eye. That physical connection connects you directly to the nuclear furnaces of distant suns. You are touching the universe, and the universe is touching you. We often ask, what keeps the universe in motion? In the case of our galaxy, it is the delicate balance between the inward pull of gravity and the outward motion of the stars. It is a stalemate that has lasted for eons. The stars want to fly off into the void. Gravity wants to crush them into the center. The result is the beautiful, graceful orbit that defines our night sky. It is a dance of tension and release, a cosmic ballet performed in silence. As you allow your breathing to slow, matching the steady rhythm of the night, picture the Earth not as a solid, immovable ground, but as a vessel. We are sailing through the sea of darkness, protected by the glowing hull of our atmosphere, guided by the lighthouse of the sun. But the ocean we sail is the Milky Way. The structure of the galaxy is not random. It follows the same mathematical patterns found in a sunflower, a hurricane, or a seashell. The spiral arms are logarithmic spirals, a shape that nature seems to prefer when organizing energy and matter. To look at the galaxy is to look at a mirror of the natural laws that govern everything from the smallest snail to the largest storm. There is a deep peace in realizing that we are part of such a grand design. We do not have to understand all the mathematics to feel the rightness of it. The galaxy does not hurry. It does not struggle. It simply turns with a majestic slowness that mocks our hurried lives. The ancient Greeks believed that the Milky Way was the path of ruin caused by the chariot of the sun, God losing control. But tonight, it feels like a path of stability. It is the silver river that flows forever without water. It is the road that leads everywhere and nowhere. As we prepare to leave the surface of the earth and travel in our minds through the structure of this galaxy, hold on to that feeling of connection. You are not an observer separate from the scene. You are a participant. The iron in your blood was forged in the hearts of giants that died long before the earth was born. The gold in your jewelry was created in the collisions of neutron stars deep in the galactic past. You are, in every way that matters, a child of the Milky Way. Let the darkness of the room wrap around you like the darkness of space, not cold and threatening, but cool and preserving. In the silence, you can almost hear the hum of the galaxy, the vibration of gravity binding the stars together. We are safe here in the Orion Spur, drifting slowly around the great cosmic wheel. The journey we are about to take will lead us away from the familiar sights of Earth. We will ascend past the moon, past the planets, and out into the glittering architecture of the spiral arms. We will witness the birth of stars and the quiet darkness of the nebulae. But for now, just for this moment, rest in the knowledge of where you are. You are on a blue planet, circling a yellow star, tucked away in the spiral arm of a barred spiral galaxy floating in the dark. The universe is vast, but it is not chaotic. It is ordered. It is rhythmic. And it is waiting for us to explore it. Rest your mind on the image of that band of light. It is the edge of our dinner plate, the rim of our wheel. It is the collective light of history. As your eyes grow heavy, imagine the slow rotation, the sun, the earth, you, all turning together in the great galactic carousel. The night is long, and the stars are patient. They have burned for billions of years, and they will burn for billions more. Your worries are fleeting shadows in the face of this enduring light. Let them drift away, pulled apart by the gentle gravity of sleep. We are awakening to the silver river, dipping our toes into the stream of starlight. The water is warm with radiation, glowing with the energy of creation. As we release our hold on the familiar landscapes of Earth, drifting upward in our imagination, the perspective shifts. We are no longer standing on the surface of a sphere looking out. We are rising above the plane of the galaxy itself. If we could journey far enough, tens of thousands of light years perpendicular to the galactic disk, and look back, the band of light that graces our night sky would reveal its true and magnificent form. We would see the architecture of a spiral. From this vantage point, the Milky Way resembles a great celestial whirlpool, a storm of light frozen in the silence of the vacuum. It is a structure of immense beauty, characterized by the graceful, curving arms that wind outward from the center. This is the spiral galaxy, one of the most common and elegant shapes in the universe. It is a shape we recognize from the natural world below. We see it in the uncurling frond of a fern, in the shell of a nautilus, and in the terrifying grandeur of a hurricane. It is a pattern that nature seems to whisper across all scales of existence, from the microscopic to the immense. For decades, astronomers believed the Milky Way was a simple spiral with 4 major arms emerging directly from a spherical core. But the galaxy is careful with its secrets. It was only in the last few decades, using infrared telescopes that can peer through the obscuring curtains of dust, that we discovered a hidden feature. We are not merely a spiral. We are a barred spiral. Running across the center of the galaxy is a massive rectangular bar of stars, perhaps 27,000 light-years long. It looks like a radiant bridge of light connecting one side of the core to the other. From the ends of this bar, the great spiral arms unfurl, trailing behind the rotation like the ribbons of a rhythmic gymnast. This structure suggests that our galaxy has reached a certain maturity, a settled state of gravitational elegance that allows such complex features to form and endure. Let us trace these arms. They are the defining features of our galactic home, the districts of the metropolis. There are 2 major arms that dominate the structure: the Scutum Centaurus arm and the Perseus arm. These are the dense, sweeping highways of the galaxy, packed with the brightest stars and the richest clouds of gas. Then there are the minor arms, the Norma arm and the Sagittarius arm, which are somewhat less dense but no less beautiful. We reside in a structure known as the Orion Spur, or the Orion Cygnus arm. It is a bridge of stars located between the Sagittarius and Perseus arms. In the grand geography of the Milky Way, we live in a quiet, suburban connector street, nestled safely between the roaring interstate highways of the major arms. This placement is fortuitous. If we were inside one of the major arms, the night sky would be dazzlingly bright, but the environment would be far more dangerous, filled with the intense radiation of giant stars and the frequent, violent detonations of supernovae. Here in the spur, we have room to breathe. We have a front row seat to the spectacle without being caught in the crush of the performance. But what exactly is a spiral arm? When we look at images of galaxies, the arms appear to be solid structures like the spokes of a wheel or the blades of a fan. It is easy to imagine that the stars are locked into these arms, moving around the center in a fixed formation. But this is an illusion of light and time. If the arms were solid structures, the galaxy would face a problem known as the winding dilemma. Because stars closer to the center complete their orbits faster than stars at the edge, a solid arm would wind up tighter and tighter until the spiral shape disappeared entirely, smearing into a featureless disk. Yet, the Milky Way has maintained its spiral shape for billions of years. How does it sustain this delicate architecture? The answer lies in the physics of waves. The spiral arms are not permanent collections of stars. They are density waves. Think of a traffic jam on a highway. As you drive, you approach a section where cars are bunched together. You slow down, you move through the congestion, and then you speed up again as you leave it behind. The traffic jam itself remains in the same place on the road, maintaining its structure, even though the individual cars are constantly flowing through it. The spiral arms are cosmic traffic jams. They are regions where gravity has compressed the gas and dust of the galactic disk. As stars orbit the galactic center, they move into these arms, slow down slightly due to the gravitational drag, and then eventually move out the other side. The arm itself is a pattern, a standing wave of gravity that rotates independently of the stars. This brings us to a profound realization. Our sun has not always been in the Orion Spur. In its long life, the sun has passed in and out of the major spiral arms many times. We are currently passing through this bridge, but in the distant future we will drift out of it and cross the void to the next arm. The geography of the heavens is fluid. The constellations we see today are temporary companions, fleeting patterns that will dissolve as we continue our journey around the wheel. How does time shape the paths of stars? It is a question that invites us to see the galaxy not as a static painting, but as a flowing river. The stars are like leaves caught in an eddy, tracing complex paths that are dictated by the invisible currents of gravity. These spiral arms are the engines of creation. As clouds of interstellar gas enter the density wave of an arm, they are squeezed. The diffuse particles are forced together, increasing the pressure and the temperature until, deep within the dark clouds, nuclear fusion ignites. The spiral arms are lit up like Christmas trees because they are the nurseries of the galaxy. They are blue and bright because they are populated by young, massive stars. These blue giants burn with a ferocity that defies the imagination. They consume their fuel in a mere few million years, living fast and dying young. Because they die so quickly, they never have the chance to drift far from the arm where they were born. They detonate as supernovae while still embedded in the spiral, illuminating the structure like lights on a runway. In contrast, the spaces between the arms, the regions where our sun will one day travel, are dimmer and redder. These gaps are populated by older stars, the long-lived survivors that have drifted out of the nursery and are continuing their quiet orbits. The arms are the celebration of youth. The gaps are the domain of endurance. The texture of the galactic disk is not smooth. If you were to fly through it, you would encounter a landscape of immense variety. There are the great rifts, dark lanes of dust that block the starlight, creating silhouettes that look like caves in the sky. These dust lanes often run along the inner edges of the spiral arms, marking the shock fronts where the gas is piling up, waiting to be turned into stars. The disk itself is incredibly thin relative to its width. The Milky Way is about 100,000 light-years across, but the main disk is only about 1,000 light-years thick. If you were to shrink the galaxy down to the size of a pizza, it would be thinner than the crust. It is a delicate, razor-thin plane of matter spinning in the void. Yet, this thinness is deceptive. Within that narrow slice of space lies almost all the normal matter of the galaxy. There is a rhythm to this structure, a grand design. While some galaxies are flocculent, looking like fluffy bits of cotton wool with no distinct shape, the Milky Way is organized. It possesses a symmetry that appeals to the human desire for order. We see the same logarithmic spiral in the head of a sunflower, where the seeds are arranged to pack the maximum number into the smallest space. We see it in the shape of a low-pressure weather system spinning off the coast. It seems that when the universe organizes energy, it prefers the spiral. As we drift along the length of the Perseus arm in our mind's eye, we encounter wonders that defy the scale of human experience. We pass the Eagle Nebula, where the famous pillars of creation stand like stalagmites in a cave of gas, light years tall, hiding newborn stars in their tips. We glide past the Lagoon Nebula, a turbulent sea of glowing hydrogen churned by the radiation of a giant star at its center. These are the landmarks of the spiral arms, the glowing jewels strung along the invisible thread of gravity. But there is also emptiness. Between the stars, the density of matter is incredibly low. The interstellar medium is a vacuum far more perfect than anything we can create in a laboratory on Earth. Yet, it is not nothing. It is a soup of atoms, molecules, and cosmic rays. It carries the magnetic field of the galaxy, a tenuous web that threads through the spiral arms, guiding the motion of charged particles. The rotation of this majestic structure is slow and silent. From our position, it takes the Sun roughly 230 million years to complete one circuit. This period is often called a galactic year. To give this scale, the last time the Sun was in this part of the galaxy, the first mammals were just appearing, tiny shrew-like creatures scurrying beneath the feet of dinosaurs. The mountains we see on Earth today, the Himalayas, the Alps, the Rockies, did not exist. They were born, rose, and will eventually erode, all within the span of a single galactic rotation. The galaxy operates on a timescale that makes geology look like a frantic sprint. This slow rotation creates a sense of stability. We do not feel the wind of our passage. The solar system is like a ship on a calm sea, moving with the current. We are protected by the heliosphere, a bubble of magnetic pressure created by our Sun, which pushes back against the interstellar medium. We are traveling in a bubble within a spiral, a protected world within a majestic design. There is a curiosity in the vertical structure of the disk as well. While the main thin disk holds the young stars and the gas, there is also a thick disk that envelops it. This thick disk contains older stars, veterans of the galaxy that bob up and down through the plane like carousel horses. Their orbits are more chaotic, taking them high above and far below the spiral arms. These stars have seen the galaxy from angles we can only imagine, looking down upon the spiral pattern from the high altitudes of the galactic atmosphere. Reflect for a moment on the forces required to maintain this shape. Gravity is the sculptor, pulling everything inward. Angular momentum is the artist, spinning the clay into a disk. But there are other forces at play. Magnetic fields twist and channel the gas. The pressure of starlight pushes against the dust. It is a dynamic equilibrium, a balancing act that has held firm for over 13 billion years. The spiral arms also act as the keepers of history. As stars are born and die, they enrich the gas of the arms with heavy elements: carbon, oxygen, iron, gold. The next generation of stars born in that arm will be richer in these metals. Our Sun is a third-generation star, born from the debris of ghosts that haunted the spiral arms long ago. The atoms in your body were once drifting in a density wave, waiting for the squeeze of gravity to bring them together. As we visualize the sweep of the Scutum Centaurus arm, try to feel the texture of the galaxy. It is not a smooth sheet of light. It is clumpy, frothy, and turbulent. It is a mixture of hot plasma and cold dust, of brilliant light and profound darkness. It is a landscape as varied as the biomes of Earth, but written in fire and ice on a canvas of light years. This architecture tells us that we are part of something structured and enduring. The Milky Way is not a random cloud. It is a machine. It processes matter. It creates light. It organizes chaos into beauty. And we are the beneficiaries of this order. Without the density waves of the spiral arms to compress the gas, star formation would be inefficient and slow. Our sun might never have been born. The Earth might never have coalesced from the protoplanetary disk. The spiral shape is not just a pretty pattern. It is the mechanism of our existence. We are travelers on the rim of a great wheel. As we look toward the constellation of Sagittarius, we are looking toward the center of the wheel, the hub around which everything turns. But looking outward, toward the constellation of Auriga or Taurus, we are looking toward the edge, the rim, where the stars thin out and fade into the intergalactic night. There is a comfort in the repetition of the spiral. It suggests that the universe has rules, that it follows a logic we can learn to understand. It is not a place of caprice, but a place of laws, and those laws have conspired to create a safe harbor for us in the Orion Spur, a quiet eddy in the great Silver River. As the image of the great spinning pinwheel settles in your mind, let the grandeur of the scale wash over you. 100,000 light years across, billions of stars, all moving in a synchronized dance to the silent music of gravity. We are small, yes, but we are also the witnesses. The galaxy spins, and we watch. The arms sweep through the void, gathering up the dust of the past to build the stars of the future. And in the quiet spaces between the arms, on a small rock orbiting a yellow star, we close our eyes and drift, carried along by the momentum of the Milky Way. The journey continues inward now. We leave the sweeping, majestic arms behind and turn our gaze toward the glow that brightens the center of the sky. We are moving toward the heart of the galaxy, toward the crowded, ancient, and mysterious bulge. As we leave the graceful, sweeping curves of the spiral arms behind us, our journey turns inward. We are moving away from the quiet suburbs of the Orion Spur, drifting across the vast distances that separate the outer rim from the inner sanctum. The journey is one of increasing intensity. The darkness of the intergalactic void, which lay at our backs when we looked outward, is now forgotten. Ahead, the sky is filling with light. We are approaching the heart of the Milky Way, the galactic bulge. From our vantage point on Earth, this region is largely hidden from view. When you look toward the constellation of Sagittarius on a summer night, you are looking directly toward the center of the galaxy. Yet, you see only a fraction of its brilliance. The Great Rift, that dark river of interstellar dust we observed earlier, acts as a heavy velvet curtain, absorbing the visible light of the billions of stars that reside in the core. For centuries, astronomers could only guess what lay behind that veil. It was a city of lights, obscured by fog. But with the advent of infrared telescopes, eyes that can see the heat of stars rather than just their light, the curtain was lifted. If you could see in infrared, the Milky Way would not look like a streak of milk. It would look like a blazing fire glowing most intensely at the center, a spherical bulb of radiance that dominates the sky. As we penetrate the dust lanes in our imagination, the first thing we notice is the change in color. The spiral arms were blue and white, studded with the diamond-hard brilliance of young, hot stars. But here in the bulge, the light warms to a golden yellow and a deep sunset orange. This is a sign of age. The stars here are the elders of the galaxy. They are red giants and orange dwarfs, suns that have been burning for 10 billion years or more. They formed when the galaxy was in its infancy, before the spiral arms had fully settled into their modern shape. Entering the galactic bulge is like entering the oldest district of an ancient metropolis, where the streets are narrow and the buildings are packed tight. In the spiral arms, stars are lonely travelers, separated by light years of empty space. In the bulge, they are neighbors. The stellar density here is staggering. In the neighborhood of our sun, there is perhaps one star for every few cubic light years. Here, in the central cubic parsec, there are millions. Imagine for a moment that our Earth orbited a star inside this crowded core. The night sky, as we know it, would not exist. There would be no dark canvas sprinkled with faint points of light. Instead, the sky would be ablaze with stars, thousands of times brighter than our full moon. It would be bright enough to read a book at midnight solely by starlight. The Milky Way would not be a band. It would be an all-encompassing glow. We would likely not know that the rest of the universe exists, for the brilliance of our own galaxy would wash out the faint light of distant galaxies. We would be cosmic solipsists, locked in a cage of light, unaware of the vast darkness beyond. This central structure is not a perfect sphere. As we drift closer, we see that the bulge is elongated. It is shaped like a peanut, or perhaps a deflated football. This is the bar of the Milky Way. It is a massive rotating structure of old stars that channels gas inward, feeding the hungry engine at the very center. The bar acts as a funnel, a gravitational highway that directs material from the disk down into the deep gravity well of the core. Navigating through this region, we encounter a chaotic environment. The radiation here is intense. The magnetic fields are twisted and powerful, snapping like rubber bands and releasing bursts of energy. We see filaments of gas that stretch for light years, looking like the strings of a harp, vibrating with magnetic tension. These are the non-thermal filaments, mysterious structures that hint at the complex weather of the galactic core. And then we reach the center. At the exact dynamic center of the Milky Way, 26,000 light-years from Earth, lies a region known to astronomers as Sagittarius A star. For a long time, it was just a radio source, a noisy patch of sky that hissed with energy. We knew something was there, something small but incredibly heavy, acting as the anchor for the entire galaxy. It is a supermassive black hole. The term black hole often conjures images of destruction, a cosmic vacuum cleaner devouring everything in sight. But here, in the calm observation of our documentary journey, let us view it differently. Let us view it as the great stabilizer. Sagittarius A star contains the mass of 4 million suns, all crushed into a space no larger than the orbit of Mercury. It is an object of infinite density, a singularity where the fabric of space and time is punctured. Around it lies the event horizon, the point of no return, the boundary where gravity becomes so strong that not even light can escape its grip. To look at it is to look at a shadow, a perfect circle of nothingness surrounded by a swirling ring of fire. This ring is the accretion disk, gas and dust that has been caught in the black hole's gravity. As the material spirals inward, moving at significant fractions of the speed of light, it experiences friction. It heats up to millions of degrees, glowing in X-rays and radio waves. It is this dying scream of matter that we detect from Earth, the beacon that told us where the center lay. But currently, our giant is sleeping. Compared to the monstrous black holes in other galaxies known as quasars, which devour stars daily and shine brighter than their entire host galaxies, Sagittarius A star is on a starvation diet. It snacks on wisps of gas and the solar wind of nearby stars. It is quiet. It is dormant. This silence is fortunate for us. A fully active galactic nucleus would bathe the galaxy in lethal radiation, perhaps sterilizing the inner spiral. Arms, though the beast is quiet, its gravity is absolute. Orbiting dangerously close to the black hole is a cluster of stars known as the S-stars. These are the daredevils of the galaxy. The most famous among them, a star named S2, swings around the black hole in a frantic elliptical orbit that takes only 16 years to complete. At its closest approach, it screams past the black hole at speeds exceeding 7,000 kilometers per second. By watching these stars over decades, astronomers have confirmed the existence of the supermassive object. We have watched S2 turn a corner in empty space, whipped around by the gravity of something invisible. It is a cosmic dance where one partner is seen and the other is unseen, yet the geometry of the dance reveals the presence of the hidden lead. What force keeps the universe in motion? Here, the answer is visceral. It is the curvature of space itself. The black hole is not pulling the stars like a magnet pulls iron. It is bending the road they drive on. They are falling freely through a curved universe, circling the drain of eternity. There is a profound philosophical weight to the galactic center. In many cultures, the center is the place of origin, the axis mundi, the point around which the world revolves. The Milky Way follows this pattern. Everything we are, every star we see, every planet and comet is slowly orbiting this dark, silent point. It is the hub of the wheel. Without it, the galaxy would not have formed in the way it did. It is the seed around which the pearl of the Milky Way has grown. Yet, despite its power, the black hole dictates the motion only of the stars closest to it. As we move further out, its influence wanes, merging into the collective gravity of the bulge itself. The sun, so far away in the suburbs, feels the pull of the black hole only as a tiny fraction of the total pull of the galaxy. We orbit the collective billions of stars, not just the one dark object. The environment near the core is hostile to life as we know it. The density of stars means that close encounters are common. Systems are jostled. Planetary orbits are disrupted. A planet here would be constantly bombarded by radiation from nearby supernovae and the flickering activity of the black hole. It is a place of high energy, a place of constant change. It is the engine room of the galaxy, hot, loud, and dangerous, in stark contrast to the quiet, pastoral hills of the Orion Spur where we reside. Above and below the galactic center, rising perpendicular to the disk like two giant balloons, are the Fermi bubbles. These are massive structures of gamma-ray and X-ray emission extending 25,000 light-years to the north and south of the core. They are the echoes of a past meal. Perhaps a few million years ago, Sagittarius A star woke up. It may have swallowed a large cloud of gas, or perhaps a star that wandered too close. The resulting indigestion caused it to burp out two colossal jets of energy, inflating these bubbles into the galactic halo. They are invisible to our eyes, but to our instruments, they stand as monuments to the power lurking in the dark. There is a mystery here as well. The laws of physics, as we understand them, begin to tremble near the event horizon. Time itself slows down. If you were to descend toward the black hole, looking back at the universe, You would see the history of the galaxy playing out in fast forward. The light of aeons would be compressed into moments. Close to the center, time is not a fixed river. It is a fluid thing, warped by mass. To think of the galactic center is to confront the concept of the sublime, that mixture of awe and terror that we feel when faced with something much larger and more powerful than ourselves. The black hole is the ultimate memento mori of the cosmos, a reminder that matter can be crushed out of existence, and yet it is also a creator. The shock waves from the center compress gas in the surrounding regions, triggering the birth of new stars. Destruction and creation are two hands of the same being, working in tandem to shape the galaxy. As we hover in our imagination, just outside the event horizon, safely suspended in the realm of thought, we can appreciate the silence. In the vacuum of space, the roar of the accretion disk is unheard. The collision of gas clouds is noiseless. There is only the visual spectacle, the swirling gold of the infalling gas, the invisible distortion of the background stars, the perfect darkness of the sphere. It is a place of extremes, yet it fits perfectly into the balance of the whole. The galaxy requires a center. It requires an anchor. Just as a hurricane needs an eye, the Milky Way needs its dark heart. We must also consider the future. The black hole is growing. Slowly, patiently, it consumes the gas that drifts its way. In the far distant future, when the stars of the galaxy have burned out and the universe grows cold, the black holes will be the last things remaining. They are the custodians of the galaxy's matter, hoarding it against the coming dark. But that is a story for an unimaginable future. For now, the center is vibrant. It is a bustling downtown of stellar activity, hidden behind the dust, powering the rotation of the great wheel. Let us pull back now. Let us retreat from the intense gravity, away from the crowded skies of the bulge. We drift outward again, feeling the grip of the black hole loosen, feeling the space open up around us. We return to the cooler, calmer regions of the disk. The image of that dark anchor remains with us, a secret buried deep within the light. It reminds us that appearances can be deceiving. The brightest part of the galaxy holds the darkest object. The most crowded place is ruled by the deepest solitude. As we drift away, the golden glow of the bulge fades into the distance, becoming once again a part of the beautiful, hazy band we see from Earth. We have seen the engine, room. We have seen the anchor. Now we must turn our attention to the cycle that keeps the galaxy alive. We must look at the birth of light itself. We are moving toward the nebulae, the great clouds of gas where the stars are born. From the ancient graveyard of the center, we journey to the nursery. Having journeyed through the dense, radiant architecture of the galactic bulge and peered into the gravitational abyss of the central black hole, we now turn our gaze outward again. We drift away from the frantic energy of the core, riding the currents of the galaxy back into the sweeping majesty of the spiral arms. It is here in the vast expanses of the disk that the Milky Way reveals its most artistic nature. We are entering the realm of the nebulae, the cosmic clouds where the cycle of starlight and shadow plays out in an eternal loop of creation and destruction. If the galactic center is the engine of the galaxy, the spiral arms are its garden. And like any garden, the cycle depends on the soil. In the context of the Milky Way, this soil is the interstellar medium. To the casual observer, the space between the stars appears to be a vacuum, a complete nothingness. But this is an illusion of our limited vision. The space is filled with a tenuous mist of gas and dust, a soup of hydrogen and helium atoms sprinkled with the carbon and silicon soot of long-dead stars. On average, this medium is incredibly thin, often just one atom per cubic centimeter. By comparison, the air you are breathing right now contains billions of molecules in the same space. Yet, because the galaxy is so vast, this thin mist adds up to a staggering amount of matter. It accounts for billions of times the mass of our Sun waiting in the dark, potential and unformed. Occasionally, aided by the density waves of the spiral arms or the shock wave of a nearby explosion, this gas begins to clump together. Gravity, the patient sculptor of the universe, begins to pull the dust into giant clouds. These are the molecular clouds, the wombs of the stars. They are cold, hundreds of degrees below zero, and they are dark. When we look at the Milky Way from Earth and see the great rift dividing the stream of stars, we are seeing these clouds in silhouette. They are blocking the light of the background galaxy, hoarding their secrets in the dark. But gravity is relentless. As the cloud collapses, the pressure builds. The atoms squeeze together, rubbing against one another, generating heat. Deep inside the cold exterior, a warm core begins to form. It spins, drawing in more and more material, growing heavier and hotter until, in a moment of cosmic alchemy, the temperature reaches 10 million degrees. Nuclear fusion ignites. A star is born. Let us travel in our minds to the most famous of these nurseries, a place visible even to the naked eye on a clear winter night, the Orion Nebula. Located in the Sword of the Hunter constellation, it appears as a fuzzy star to the unaided eye. But up close, it is a cavern of light. It is a turbulent, chaotic landscape of gas, spanning 24 light-years across. In the center of this nebula lie 4 massive, brilliant stars known as the trapezium. These are newborn giants, only a few million years old. They are not merely illuminating the gas around them, they are boiling it away. Their intense ultraviolet radiation acts like a wind, eroding the cloud, carving out a vast cavity in the nebula. The glowing walls of this cave are painted in hues of electric pink and emerald green, the fingerprints of excited hydrogen and oxygen atoms. To float through the Orion Nebula is to witness a violent beauty. We see proplyds, or protoplanetary disks, teardrop-shaped cocoons of gas surrounding infant stars. These are solar systems in the making. Inside those dark knots, planets are coalescing from the dust. It is a glimpse into our own past. 4.5 billion years ago, our Sun was just one of these sparks in a similar cloud, and the Earth was just a handful of dust grains beginning to stick together. There is a philosophical resonance in looking at a nebula. We are seeing the universe in its most creative state. It asks us, what does cosmic perseverance teach us about our own lives? It teaches us that chaos often precedes creation. The turbulence of the nebula, the collision of particles, the violent radiation, these are not signs of disorder, but the necessary conditions for the birth of light. Out of the dark and the cold comes the warmth of a new sun. The galaxy is not just a factory for single stars, it often births them in litters. The nebulas give rise to open clusters, families of hundreds or thousands of stars born from the same cloud at the same time. The Pleiades, or the Seven Sisters, is one such family. These blue, jewel-like stars are currently passing through a wisp of unrelated dust, illuminating it with a ghostly blue reflection. This is a reflection nebula, shining not by its own light, but by mirroring the brilliance of the stars within it. These clusters drift through the galaxy together for a time, but the gravitational shear of the Milky Way eventually pulls them apart. Our own Sun was once part of such a cluster, surrounded by thousands of siblings. Over the eons they have drifted away, lost in the crowd of the galactic disk. When you look up at a random star, you might be looking at a long-lost brother of the Sun, separated by the drift of time. But the cycle does not end with birth. For the galaxy to live, stars must also die. The death of a star is as crucial to the galactic ecosystem as the decay of leaves is to a forest floor. When a star like our Sun reaches the end of its life, it does not simply vanish. It swells into a red giant, engulfing its inner planets, and then gently puffs its outer layers into space. This glowing shell of gas, illuminated by the dying ember of the star's core, a white dwarf, is called a planetary nebula. The name is a misnomer, a relic of 18th century astronomers who thought these round, fuzzy objects looked like planets. In reality, they are the beautiful tombstones of stars. The Helix Nebula, often called the Eye of God, is a perfect example. It looks like a giant golden eye staring back at us across 700 light years. These structures are ephemeral, lasting only a few tens of thousands of years before they dissipate into the interstellar medium. But in that short time, they are among the most colorful objects in the universe, painting the dark with rings of red, blue, and gold. For more massive stars, the end is far more dramatic. A star 8 or 10 times the mass of the Sun does not go gently. It burns through its fuel with voracious speed, fusing hydrogen to helium, then helium to carbon, neon, oxygen, and silicon, climbing the periodic table in a desperate bid to maintain equilibrium against gravity. Finally, it creates iron. Iron is the star killer. Fusing iron consumes energy rather than creating it. The balance is broken. In a fraction of a second, the core collapses. The outer layers rush inward at 25% of the speed of light, hit the immovable neutron core, and bounce off in a cataclysmic explosion, a supernova. For a few weeks, a single supernova can outshine the entire galaxy. It releases more energy in a moment than our Sun will create in its entire 10 billion year lifetime. But it is what happens inside the explosion that matters most to us. In the intense heat and pressure of the blast, the universe forges the heavy elements: gold, silver, platinum, uranium. These are not created in the normal life of a star. They are created in its violent death. This brings us to a profound truth. The galaxy is a recycler. The gas clouds of the early universe were composed only of hydrogen and helium. They could not form rocky planets. They could not form water. They could not form you. It was only after generations of stars lived, died, and exploded, enriching the clouds with heavy metals, that a system like ours could form. Every atom of carbon in your muscles, every atom of calcium in your bones, every atom of iron in your blood was forged inside a star that died long before the Earth was born. We are, quite literally, ghosts of the stars. We are the way the universe has found to know itself. When you look at your hand, you're looking at the dust of a nebula that has been rearranged by the exquisite laws of chemistry and biology. How does time shape the paths of stars? It turns them into dust, and then turns the dust back into stars. This is the great galactic respiration. The Milky Way breathes. It inhales gas and exhales starlight. It inhales dead stars and exhales new worlds. Let us visualize this cycle on a grand scale. we see the shock waves from a supernova expanding like a bubble, sweeping up the interstellar gas. This shock wave hits a nearby cloud, compressing it, triggering the birth of a new cluster of stars. One death triggers 1,000 births. It is a chain reaction that has continued for 13 billion years, a fire that keeps itself burning. As we drift through the Perseus Arm, we encounter the Crab Nebula. It is the wreckage of a star that exploded in the year 1054. Chinese astronomers recorded it as a guest star, visible even in the daytime. Today, it is a tangled web of filaments expanding outward at millions of kilometers per hour. At its center spins a pulsar, the crushed core of the original star, a city-sized ball of neutrons spinning 30 times a second, sending a beam of radio waves sweeping across the galaxy like a lighthouse. It is a monument to the violence of the cosmos, yet it is also a seed pod, scattering heavy elements into the void to fertilize the next generation. There is a stillness in this realization. The violence of a supernova is not tragic, it is generative. The darkness of a molecular cloud is not empty, it is pregnant with potential. The galaxy is not a static collection of objects, but a flowing, changing, living process. The colors of the nebulae tell us the chemical story of this process. When we see the deep, rich reds in photos of the cosmos, we are seeing hydrogen gas being energized by ultraviolet light, a process called fluorescence, similar to how a neon sign glows. When we see blue, we are often seeing starlight scattering off dust grains, the same physics that makes the sky blue on Earth. When we see dark, inky patches, we are seeing the density of the dust itself, silhouetted against the background fire. It is a painting that constantly repaints itself. The nebula you see today will not be there in 1,000,000 years. The stars will have blown it away, or gravity will have consumed it. The Pleiades will disperse. The Orion Nebula will dissipate. New clouds will form in new places. The face of the Milky Way is ever-changing, a slow-motion kaleidoscope of light and shadow. As we observe these stellar nurseries, we must also recognize the silence of the spaces between them. The cycle is efficient, but it is not perfect. Not all gas becomes stars. Some of it is blown out of the galaxy entirely by the galactic wind, a stream of particles driven by the collective energy of the stars. Some of it falls into the black hole at the center, but much of it simply waits, suspended in the magnetic fields of the disk, biding its time. There is a sense of deep time here. A star like the Sun lives for 10 billion years. A massive star lives for 10 million. A red dwarf might live for 1 trillion. The galaxy is a community of mixed ages, a civilization where the ancestors and the descendants live side by side. The light hitting your eyes from the Milky Way is a composite image. The blue light of the young, the yellow light of the middle-aged, and the red light of the ancients, all blending into the singular glow of the galaxy. This section of our journey asks us to appreciate the transient nature of all things. Even the stars, which seem so eternal to us, are mortal. They are born, they live, and they die, but in their death, they ensure the continuity of the whole. The Milky Way survives because its constituents change. It is stable because it is dynamic. Rest your mind on the image of the Eagle Nebula's pillars of creation, 3 towering columns of cold gas, light years high, standing against the ultraviolet erosion of nearby stars. They look like statues in a cathedral, timeless and stoic. Yet we know they are evaporating. They are temporary structures sandcastles on the cosmic beach. But within them, right now, stars are condensing. The cycle continues. As we prepare to leave the rich, gas-filled plain of the galactic disk, take a moment to feel the warmth of this process. You are a child of this cycle. The atoms in your body have been on a journey through nebulae, through stars, through supernovae, and through the cold dark of space, finally coming together to form you. You are the universe waking up. The disk, with its spiral arms and glowing nebulae, is the visible body of the galaxy. It is where the action is, but it is not the whole story. As we have learned, the universe is often dominated by what we cannot see. There is a presence surrounding us, a ghost that haunts the outer reaches of the Milky Way. We must now ascend. We must leave the flat plane of the spiral, rise above the glowing clouds and the diamond stars, and venture into the vast, spherical emptiness that surrounds the galaxy. We are heading into the halo. We are moving toward the mystery of the invisible matter that holds it all together. The lights of the disk are fading below us. The familiar spiral shape recedes. We are entering the domain of the ancients and the realm of the dark. As we ascend, leaving the luminous, cluttered plane of the galactic disk far below us, the view changes dramatically. We have spent our journey thus far within the crowded city limits of the Milky Way, surrounded by the neon glow of nebulae and the bright streetlights of young stars. But now we are heading into the high country. We are entering the galactic halo. If you were to view the Milky Way from this distance, tens of thousands of light years above the spiral arms, the galaxy would look like a fried egg. The yolk is the bright, bulging core we explored earlier. The white is the thin, spreading disk of the spiral arms. But there is more to the egg than just the visible parts. There is the shell. The halo is a vast, spherical region that encompasses the entire galaxy, extending far out into the intergalactic void. Here, the sky is profoundly dark. The dust lanes that choke the view inside the disk are gone. The air is clear, so to speak, but scattered across this darkness, like diamonds resting on black velvet, are some of the most beautiful and ancient objects in the universe, the globular clusters. Imagine a ball of light, so dense at the center that the individual stars merge into a single blaze of glory, tapering off at the edges into a dusting of sparkles. This is a globular cluster. There are about 150 of them orbiting the Milky Way, acting as satellites to the main galaxy. They are cities unto themselves, tightly packed communities of stars that have stayed together for billions of years. Let us drift toward one of the finest examples, Omega Centauri. To the naked eye on Earth, it is a faint smudge in the southern sky. Up close, it is a metropolis containing 10 million stars. But unlike the open clusters in the disk, those loose, temporary families of young stars, the globular clusters are permanent. These stars are bound together by a gravity so strong that they can never escape one another. They are destined to dance together until the end of time. The stars here are not the blue, hot giants of the spiral arms. They are red and gold, cooling embers that have been burning since the very dawn of the galaxy. These clusters are the nursing homes of the Milky Way. The stars within them are roughly 12 billion years old, almost as old as the universe itself. They were born before the disk of the galaxy had even flattened out, before the heavy elements like carbon and iron were plentiful. As a result, these stars are metal-poor, pristine samples of the primordial gas from which everything emerged. If you lived on a planet orbiting a star inside a globular cluster, you would never know night. The sky would be filled with thousands of stars brighter than Venus, casting shadows in every direction. It would be a perpetual twilight of golden radiance. But you would likely be alone in the universe in a different way. The lack of heavy elements suggests that rocky planets like Earth are very rare in these ancient clusters. It is a beautiful, barren cage of light. Beyond these glittering clusters, the halo is lonely. There are field stars out here, solitary wanderers that have been kicked out of the disk by gravity, or were born in the chaotic early days of formation. They travel in long, looping elliptical orbits, diving through the galactic disk and soaring back out into the dark, like dolphins jumping through the surface of the ocean. But the halo is not just a quiet retirement home. It is also a crime scene. As we peer into the darkness surrounding the Milky Way, we begin to see faint ribbons of light wrapping around the galaxy. These are stellar streams. They are the stretched-out remains of dwarf galaxies that ventured too close to the Milky Way. Our galaxy is a cannibal. Over the eons, it has used its superior gravity to capture smaller satellite galaxies, ripping them apart and absorbing their stars. The Sagittarius Stream is one such ghost. It is a river of stars that wraps around the Milky Way over the top, a celestial scarf worn by the galaxy. It is the debris of the Sagittarius dwarf galaxy, which is currently being digested by our home. This violence is slow and silent. It takes billions of years for a dwarf galaxy to be pulled apart, its stars strung out like pearls on a necklace before finally merging with the halo. This tells us that the Milky Way did not just form, it grew. It was built from the accumulation of smaller neighbors, a process that continues to this day. However, the true mystery of the halo is not what we can see, but what we cannot. For decades, astronomers looked at the Milky Way and assumed that what they saw was what existed. They counted the stars, they measured the gas, and they calculated the mass of the galaxy based on this visible light. It seemed straightforward. The galaxy is a collection of shining objects held together by their mutual gravity. But in the 1970s, when astronomers like Vera Rubin began to measure the speed at which stars orbit the galaxy, they found something impossible. In our solar system, the rules are clear. Mercury, close to the Sun, moves very fast. Pluto, far from the Sun, moves very slowly. This is Keplerian motion. The farther you are from the source of gravity, the slower you should orbit. Astronomers expected the galaxy to work the same way. The stars at the edge of the disk, far from the heavy bulge, should be moving slowly, but they are not. The stars at the outer rim of the Milky Way are moving just as fast as the stars near the center. By all the laws of physics based on visible matter, they should be flying off into deep space. The gravity of the visible stars and gas is nowhere near strong enough to hold onto them at those speeds. The galaxy should be tearing itself apart like a spinning flywheel that is turning too fast. Yet, the galaxy holds together. The spiral arms remain graceful and intact. The stars stay in their orbits. This discrepancy led to one of the most profound discoveries in the history of science. There is something else there. There is a source of gravity that we cannot see, cannot touch, and cannot detect with any telescope. It does not emit light. It does not reflect light. It does not block light. It interacts with nothing except through gravity. We call it dark matter. It is a name that sounds ominous, but it is simply a placeholder for the unknown. Dark in this sense means invisible, and it is not just a small correction. To explain the speed of the stars, there must be 5 times as much dark matter in the galaxy as there is normal matter. Think of the Milky Way, not as a disk of stars, but as a giant sphere of dark matter. The visible galaxy, the glowing stars, the nebulae, the black holes, the planets, and us, is just a tiny accumulation of sediment that has settled in the center of this vast, invisible ocean. We are the foam on top of the wave, thinking we are the ocean, when in reality the water beneath is deep and unseen. The halo we are drifting through now is the realm of this dark matter. It extends far beyond the visible edge of the stars, perhaps hundreds of thousands of light years into the void. It forms a massive, invisible scaffolding that holds the galaxy together. Without dark matter, the Milky Way would have disintegrated long ago. The sun would have been flung into the intergalactic darkness. We owe our existence to this ghost. What is it? We still do not know. It is not black holes. It is not dark gas. It is not rocky planets hiding in the dark. It appears to be a fundamentally different type of particle, something that passes through the earth, through your house and through your body every second without you ever feeling it. It is a shadow universe, occupying the same space as us, yet completely separate. What does cosmic perseverance teach us about our own lives? Perhaps it teaches us that what is essential is often invisible to the eye. The structure that holds our world together, the gravity that binds the stars, arises from a source we cannot perceive. We navigate our lives by the light, but we are sustained by the dark. This invisible halo connects us to the rest of the universe. The dark matter does not stop at the edge of the galaxy. It forms filaments, vast bridges of invisible mass that stretch across the cosmos, connecting galaxy to galaxy. The Milky Way is just a node in a cosmic web, a junction point in a lattice of dark matter. The galaxies are like dewdrops strung along the threads of a spider web. As we float here in the high silence of the halo, the sensation is one of profound isolation, but also of safety. We are wrapped in a cocoon. The dark matter is the womb that keeps the galaxy stable. It protects the fragile disk from the chaos of the intergalactic medium. The silence here is absolute. The roar of the supernova in the disk does not reach this far. The radiation of the central black hole is just a faint whisper. Here time seems to stop. The globular clusters tick away the eons with the slow burning of their red stars. The stellar streams flow like silent rivers. The dark matter waits, patient and enduring. It is humbling to realize that everything we have ever seen, every star, every galaxy, every atom in our bodies, is the minority of the universe. Normal matter, the stuff of protons and electrons, makes up less than 5% of the cosmos. The rest is dark matter and dark energy. We are the exception. We are the rare glowing jewels in a universe made of shadow. But there is beauty in the shadow. Without it, there would be no structure. Without the extra gravity of the dark matter halo, the gas in the early universe would not have collapsed to form galaxies in the first place. There would be no stars to light the dark. Dark matter is the midwife of light. As we look back down at the spiral disk from our high vantage point, it looks fragile, a thin, shimmering plate of light spinning in the void. It looks like it could be shattered by a breath, but we now know it is held in a grip of iron. The invisible sphere surrounds it, locking the stars in their paths, ensuring that the sun returns to its place in the spiral arm, ensuring that the dance continues. The halo is also the frontier. It is the borderland between home and the infinite. Beyond the edge of the dark matter halo lies the true void, the deep space between galaxies where the density of matter drops to almost zero. To cross that boundary is to leave the island and enter the ocean. But even here, in the quiet suburbs of the galaxy, there is motion. High-velocity stars, kicked out of the center by the black hole, streak through the halo at millions of kilometers per hour. They are on a one-way trip, destined to escape the galaxy entirely and wander the lonely spaces between the island universes forever. They are the exiles, the hypervelocity travelers who have broken the chains of gravity. And there is gas here too, the galactic corona. It is a hot, diffuse mist that surrounds the galaxy, extending out into the halo. It is so thin, it is almost a vacuum, yet it contains more mass than all the stars in the disk combined. It acts as a reservoir, slowly raining gas down onto the disk to fuel the formation of new stars. The galaxy recycles its own exhaust, catching it in the halo and letting it fall back in a cosmic rain. So, the halo is not empty. It is full of history, full of mystery, and full of the invisible substance that makes existence possible. It is the grandest part of the Milky Way, the container for all the rest. As we linger in this high, dark place, let the concept of the invisible wash over you. There is a comfort in knowing that there are forces holding us that we do not need to understand to benefit from. We do not need to see the dark matter to be held by it. We do not need to feel the rotation of the galaxy to be part of it. We are carried, we are suspended in a great, invisible sphere, drifting through the dark, protected, bound, and connected. The mystery is not a source of fear, but of wonder. The universe is larger than our senses, deeper than our vision, and more complex than our understanding. And now, having explored the body of the galaxy from the burning core to the invisible halo, we must look to the fourth dimension. We must look at time. We must ask, where is this all going? What is the destiny of this great silver river? We turn our gaze forward into the deep future. We look toward the constellation of Andromeda, where a faint smudge of light is growing larger every era. The dance is not over. The greatest step is yet to come. As we stand on the precipice of the present, looking out from the invisible scaffolding of the halo, we realize that the story of the Milky Way is far from over. We have traced its history from the primordial gas clouds to the glittering spiral arms, and we have peered into the dark machinery of its core. But a galaxy is not a static monument. It is a river that flows through time, and the river has a destination. To see the future, we must look toward the constellation of Andromeda. There, visible to the naked eye as a faint, fuzzy spindle of light, lies our nearest major neighbor, the Andromeda Galaxy. It is a sister world, a spiral city larger and more massive than our own, currently located 2.5 million light-years away. In the vast silence of the intergalactic void, it hangs like a lantern, but it is not hanging still. While most of the universe is rushing away from us, carried apart by the relentless expansion of space, Andromeda is different. It is falling toward us. Locked in a gravitational embrace that began billions of years ago, the Milky Way and Andromeda are moving toward one another at a speed of 110 kilometers per second. It is a cosmic closing speed that defies comprehension, yet the distances are so great that the gap will take eons to close. This is the ultimate destiny of our home. We are not an island universe. We are one half of a binary system, two giants circling each other in the dark, destined to become one. Let us accelerate the clock. Let us move forward in time, leaving the familiar era of human history behind, watching the stars wheel overhead as the millions of years tick by like seconds. In 2 billion years, the view from Earth, if Earth still exists, will have changed dramatically. The band of the Milky Way will still arc across the sky, but the patch of light that is Andromeda will have grown. It will no longer be a smudge. It will be a distinct, glowing disk, rivaling the moon in size. It will be a second galaxy in our sky, a looming presence that grows brighter with every passing epoch. By 4 billion years from now, the dance will have reached its crescendo. Andromeda will fill the horizon, its spiral arms, laced with dark dust and brilliant blue stars, will stretch across the night, interwoven with our own Milky Way. The night sky will be a spectacle of two distinct bands of light, crossing and mingling. It would be a sight of terrifying beauty, a ceiling of galactic fire. At this point, the gravity of the approaching giant will begin to distort the Milky Way. The delicate flat disk we call home will buckle. The invisible tidal forces will pull at the spiral arms, stretching them out into long, chaotic streamers. We will lose our shape. The order of the spiral will give way to the chaos of the collision. But collision is perhaps the wrong word. It suggests a violent crash, metal on metal, rock on rock. But galaxies are mostly empty space. The distance between stars is so vast that when two galaxies merge, the stars themselves almost never collide. They pass each other like ghosts in a fog. If the sun were a grain of sand in Paris, the nearest star would be another grain of sand in Berlin. You could throw the sand of two beaches together, and the grains would rarely touch. So, the solar system will be safe from destruction. We will not be smashed. Instead, we will be displaced. The sun, along with its retinue of planets, will be picked up by the gravitational currents and flung into a new orbit. We might be cast out into the remote halo, far from the light of the new core, or we might be pulled into the deep, crowded center. We will be travelers in a new land. As the two cores approach each other, the gas clouds, which are much larger than stars, will collide, and here there will be fireworks. The compression of the gas will trigger a firestorm of star formation. The sky of this future era will be ablaze with thousands of new nebulae, thousands of supernovae popping like flashbulbs at a concert. It will be the final, great party of the galactic era, a burst of light before the settling of the dust. The two supermassive black holes, the one at the heart of the Milky Way and the one at the heart of Andromeda, will find each other. They will spiral inward, dancing a slow waltz of gravity. As they draw closer, they will ripple the very fabric of space-time, sending out gravitational waves that will hum through the universe. Eventually, they will merge, becoming a single, colossal entity, the monarch of a new kingdom. When the dust settles, roughly 7 billion years from now, the spiral shapes will be gone. The beautiful arms, the flat disks, the dark dust lanes, all will have been scrambled and smoothed out. The result will be a new kind of galaxy, a giant elliptical galaxy. Astronomers have already given it a name, Milkomeda. It will be a vast, football-shaped ball of stars. It will not have the blue brilliance of the spiral arms, for the gas will have been used up or blown away. It will be a golden galaxy populated by redder, older stars. It will be a quiet place, The era of frantic starbirth will be over. Milkomeda will be a stable, enduring cathedral of light, floating peacefully in the void. And what of us? What of the Earth? This future plays out on a timescale that is intimately tied to the life of our own sun. Around the same time that Andromeda begins its final approach, our sun will be reaching the end of its life. Before the galaxies merge, the sun will exhaust its hydrogen fuel. It will swell into a red giant, growing so large that it will swallow the orbits of Mercury and Venus. It may stop just short of the Earth, or it may consume our planet entirely. If the Earth survives, it will be a scorched cinder world, orbiting a dying ember. But do not let this bring sadness. It is the nature of things to change. The atoms that make up the Earth, the water that fills our oceans, the air in our lungs, it will all still exist. It will simply be part of the new cycle. Perhaps the material of our solar system will be blown off into the new galaxy, coalescing into a new nebula, eventually forming a new star and a new world in the golden skies of Milkomeda. The pattern repeats. The substance remains. What does cosmic perseverance teach us about our own lives? It teaches us that every ending is merely a transformation. The destruction of the Milky Way as we know it is also the birth of something larger. The death of the sun is the release of its material back to the cosmos. There is no true loss in the universe, only rearrangement. As we look even further forward, past the collision, past the formation of the great elliptical galaxy, we peer into the deep time. The universe is expanding. The distant galaxies, those not bound to us by gravity, are rushing away faster and faster. In the far future, billions of years from now, they will disappear from view entirely. Their light will be stretched so thin by the expansion of space that it will no longer reach us. Future civilizations living in Milkomeda might look up and see only their own galaxy. They might think they are the entire universe, an island of stars surrounded by an endless, empty dark. They will not know of the Big Bang. They will not know of the drifting web of galaxies. They will see only the golden swarm of their own home. Slowly, very slowly, the lights will go out. Star formation will cease. The last blue stars will explode. The yellow stars, like our sun, will fade into white dwarfs. The red dwarfs, the misers of the cosmos, will burn for trillions of years, but eventually, even they will exhaust their fuel. The galaxy will enter the era of degenerate stars. The sky will be dark, punctuated only by the faint, cooling embers of white dwarfs and neutron stars. The black holes will reign supreme, drifting through the graveyard of the galaxy, occasionally swallowing a wayward remnant. This sounds like a lonely destiny, but there is a profound peace in it. It is the great quiet. The universe, having spent eons in a frenzy of activity, exploding, colliding, burning, spinning, will finally rest. It is the long sleep of the cosmos. Entropy will smooth out the differences, ironing out the wrinkles of energy. But that is a future so distant, it is almost abstract. For us, here and now, the galaxy is in its prime. It is vibrant, active, and alive. We are living in the stelliferous era, the age of stars. We are lucky. We have eyes to see the glory of the spiral arms. We have minds to comprehend the black hole at the center. We have the capacity to wonder. As we bring our journey to a close, let your mind drift back from the far future. Come back from the golden glow of Milkomeda. Come back from the collision. Come back to the present. Visualize the Milky Way as it is tonight, a silent, shimmering band of light arcing over a sleeping world. It is a protective blanket, a roof over our heads. We are safe here. The collision with Andromeda is an eternity away. The death of the sun is a story for the far distant future. Right now, the Earth is turning. The sun is hidden, but it will rise again. The stars are burning steadily, fusing hydrogen into helium, creating the light that guides us. Gravity is holding you to your bed, just as it holds the moon to the Earth and the sun to the galaxy. It is the same force. You are held by the same embrace that holds the stars. Feel the stability of that connection. You are not adrift. You are anchored. You are part of a system that has survived for 13 billion years and will survive for billions more. The journey we have taken, from the waking curiosity on Earth, through the spiral arms, into the crowded bulge, past the dark center, through the colorful nebulae, out into the invisible halo, and finally into the endless future, is a circle. We end where we began, with you, the observer. You are the universe experiencing itself. You are the way the Milky Way knows it exists. And now, your duty to observe is done for the day. The galaxy will continue its rotation without your help. The stars will keep their courses. The spiral arms will keep sweeping through the dark. You can let go. Imagine the great wheel of the galaxy turning slowly, majestically in the silence. It is a motion so smooth it feels like stillness. Let your breathing match that rhythm. Slow, steady, deep. The silver river flows on. The mist of starlight wraps around you. The darkness is not empty. It is full of potential. It is the canvas upon which the dreams of the universe are painted. As the narration fades, let the image of the beautiful spiral Milky Way remain in your mind's eye. A spinning jewel in the vastness, a home. Drift along the current of that river. There are no more distances to cross. There are no more facts to learn. There is only the quiet. There is only the sleep. The stars are your nightlight. The galaxy is your cradle. And the universe is singing you a lullaby of silence. Sleep now amidst the stars.